Well, hey there, Jessica Coulter here. I am the CEO and founder of Ace Cookie Tutoring. Today I want to talk to you about the science practice questions that you guys have done. So this video will be all about that practice test that's located in the group. So hopefully you've had a chance to complete that. And if you haven't, I would go ahead and pause the video and work on that before revealing the answers. Alright, here it is just in case, the link for the practice test. So if you haven't gone to the group yet and looked under files or documents, here is that link for the science practice test. Alright, so after you've completed that practice test, make sure you grade your questions, see how you did. And when you're ready, we'll go ahead and move on into explaining how these questions are done. Okay, so now we're ready to work on question number 21, and it says, of the wires tested, resistance increases for any given material as which parameter is decreased. So before we get into this, I want to point out something very important when it comes to the science section, and that is to pay attention to details. So this question says, resistance increases, and then it says a parameter is decreased. So we have to make sure we pay attention to those words. Okay? And also another thing to notice here, we've got resistance and resistivity on our table. So make sure you know which column to look at. Okay? So column is up and down. So we're going to look at this resistance. We're not going to care what the material is. All we're looking for is when resistance increases and then a parameter decreases. Something to notice here, that these values of resistance, they're not in order. Okay, so it's not going to be as simple as, oh, well, it goes up, then it goes down, or it goes down, then it goes up. Okay, so make sure you notice A, we're looking at resistance, and B, we're looking for a parameter that decreases. So the correct answer here is cross-sectional area. So we really need to also look at this column. Okay. Well, thank you so much for tuning in. I hope you're getting a lot of value out of this presentation and learning a lot that will help you on the ACT and the science section. Just want to take a moment to let you know that we are on Facebook. So if you'd like to follow Ace Cookie Tutoring, just go to that link on your screen, www.facebook.com/Ace Cookie Tutoring. We'd love to have you as a follower and keep you up to date. We'll be posting daily resources, our monthly special, and all sorts of other good stuff like that on our page. So make sure you get that in your news feed. So now let's work on question 22. This is probably the hardest question of the practice questions. So if you missed this one or your students struggle with that, this one, not at all surprising. So 22 says, given the data in the table, which the following best expresses resistance in terms of resistivity, cross-sectional area, and length. So this one's high difficulty because you're not just reading info off of the chart. All right? So we can look at the chart and figure out some relationships, but we need to know how to apply those relationships into an expression. Okay? So that might be easy for a student, it might not be. So we see from the table that resistance, okay, so that's over here. So resistance increases when resistivity increases and when length increases, but resistance decreases as cross-sectional area increases. Okay, so I know that was a lot because it's going to use everything in the table. Okay, I mean it's not really using the material, but it's using everything else. So I'll say it again. And this is something you can see from the chart, but I'm just going to write it out. So resistance, so that is increasing, okay? And then that's increasing when resistivity, or resistivity, but I do believe it's resistivity, increases. And then we also have length increase. Okay? But then it says resistance decreases as cross-sectional area increases. So we need to think about inverse and direct relationships. And like I said, this is higher level thinking, so if your student hasn't taken a lot of upper level math or science classes, this might be really hard. But when we have direct, we multiply, and when we have inverse, it's divide. The correct answer here is G. Alrighty, woo, I hope you did well on 22. I know that was not an easy problem, but maybe that was super easy for your student and that's how he or she thinks. So kudos to you. We're going to go ahead and move on to 23. And 23 says, which of the following wires would have the highest resistance? So we're back to resistance here. Now I want you to realize we're looking at our answer choices. So I told you to make sure you pay attention to details. Well, let's look at this. We have 1 centimeter, 2 centimeter. Then I have 1 centimeter, and I have 2 centimeter. Okay, so that's something we're going to have to decide. Is it 1 or is it 2 on the centimeters? So that's the first part. And then look, we've got aluminum and aluminum. And I have tungsten, and then I have tungsten. So we're deciding two things here. We're deciding is it 1 or 2 centimeters, and then we're deciding is it aluminum or is it tungsten. Now if we look over at the chart, one of our problems here, depending on how well your student knows his or her atomic symbols, under material, we don't see aluminum, we don't see tungsten. So how are we going to figure out which one is which? Well, if your student knows his or her symbols, it's really easy. We know that W is tungsten, and then we know Al is aluminum. So if your student knows that, great, that's going to save him or her some time. Otherwise, we can look in the passage. So we haven't talked about the passage yet, and that's because I always encourage students not to read anything that's not necessary. Okay? So if your student knew their atomic symbols, there'd be absolutely no reason to look at the passage. If your student doesn't know those, then what I would have encouraged is to skim or scan and looking for aluminum and tungsten. So once we've got that part down, the next step is to decide what to do about this 33, this 0.33 millimeter squared. Now you'll hopefully notice that that is in each problem, in each answer choice. So I've got two choices. I can either decide to disregard it because it's the same for all of them, so it must not be all that important, or I can go, oh, well, there must be some kind of relationship here between resistance and then length, and I can see that here in the chart. Okay. Now I can decide if it's 0.33 with this cross-sectional area, then that relationship must be the same. It has to be the same between tungsten and aluminum no matter what the length is. Alright, so we're looking at length, we're looking at cross-sectional area, we're looking at material for this problem. So really now that we've decided 0.33 is not important, we gotta decide is it 1 centimeter, 2 centimeter, is it tungsten or aluminum? So for this answer, for number 23, the correct answer is D as in David. Okay? So this one, not too hard, as long as you pay attention to those little details and don't get deterred by 0.33. Well, hey there again. How is the science section going for you? I hope it's going well. I hope you're learning a lot. If you're really struggling with the science section or maybe a different section of the ACT or even a different subject in school not related to the ACT, would absolutely love to work with you one-on-one in person or through Zoom. So if you'd like to check out the different ACT packages or book a lesson, just go to that link on your screen, acecookietutoring.com/book online. So now let's work on problem 24. The question says, according to the information given, which of the following statements is or are correct? So this is just like a problem we had in the reading section. So it's going to take a little bit of time. So it's up to you, your student, whether or not he or she can move quickly enough to make this one worth it. Otherwise, this is probably one I would skip just because it will take a little bit of time. But to decide how to do this problem, we need to look at this diagram. So we haven't looked at this yet. That's something I can't 100% guarantee, but I think is more than a little likely, is that you're going to use everything per passage in the science section. So there should be some question that will require the table, at least one, at least one question that requires a diagram, everything like that. The only reason you might not is if you look at these answer choices, 1, 2, and 3, and your child is all about electricity. Maybe he or she knows all about diameter and gauge. Maybe that's just something that makes perfect sense to him or her. If that's the case, then there's no reason to look at the diameter. It's kind of counterintuitive to know that the bigger the gauge, the smaller the diameter. At least it is for those of us that aren't, electricity nerds or whatever the right word might be. That's something else here we need to look at. Is we've looked at table 1 for our other problems, but we haven't seen anything about conductivity. We've got material, resistivity, length, cross-sectional area, and resistance, but there's nothing about conductivity. So we're going to have to look in the passage to find out something about conductivity. So if I look at the very first sentence of the passage, it says, resistance of a conductor is the extent to which it opposes the flow of electricity. And then it says resistance depends not only on the conductor's resistivity, but also on the conductor's length. So if you're kind of wondering, okay, where is that word conductor? Where is that word about resisting? We have to make some inferences here. So we've got to realize the lower the resistance, the better the conductor material is. Or we've got to realize the greater the resistance, the more opposition. So hopefully that makes sense. Resistance equal opposition. Maybe not necessarily with electricity, but maybe from a history lesson or something like that. We hopefully can make that connection. Greater resistance, more opposition. So once we've got those concepts down, looking at diagram 1 to learn about diameters and gauge, and then learning about resistance and conductivity, we can figure out that the correct answer is J. So make sure your child eliminates answer choices. As soon as he or she finds out, oh, 2 is not right, then eliminate all of the answer choices with 2 in there and go from there. Okay, 2 more questions to go. Let's work on number 25. It says, which of the following graphs best represents the relationship between the resistivity of a tungsten wire and its length? So here we are, we've got 4 different graphs, and we are looking at only tungsten. Okay, and hopefully we remember tungsten was W. So I don't care about anything else today for this problem except tungsten. And then it says resistivity and length. So then I'm really just narrowing it down here. So that's part of the science section, is being able to interpret relationships between different variables. So if we look there on that little square I marked, we see that those numbers are all the exact same. Resistivity doesn't change if the length changes. So because of that, I know the answer is D. I know this picture is not the greatest, but it's just a straight line. Oops. Let's make that a horizontal line. There we go. So that is the correct graph for number 25. And something I want to make sure I point out is the ACD can be tricky in the science and math sections when it comes to graphs, make sure your axes are labeled correctly, because they will try to do them opposite to throw you off. All right, here is question 26. It is the last question of the practice test. So congratulations for making it this far. Number 26 says, if the length of the wires were increased to 4 centimeters, what effect would this most likely have on the wire's resistance values? All right, so something I want to point out. We talked about grouping questions together in the reading section. I encourage the same thing in the science section. So question 26, I would do right after or back to back or same time as 22 and 24. Because in question 24, we had to look at this diagram, and that's something else we're going to need to do here in this question. And then we also need 22. Now 22 is that kind of gross one depending on how well your child did with inverse and direct relationships. But back to 26 here. Correct answer is J. And like I said, that has to do with looking at diagram 1, and then it also requires us to look back at table 1, and we're looking at resistance, and then we're looking at length. All right, so we see that resistance increases for all metals when length increases. Well, that is everything I have for you. So thank you so much for watching this video. Hope it helped, and I hope the science section goes better for you now that you have some new strategies to use. But if you are still struggling and would like some one-on-one help, maybe with the ACT or another subject unrelated to the ACT, or maybe if I'm talking to mom or dad, you've got another kiddo that could use some help, feel free to book a lesson at acecookie-tutoring.com/book online. Would love to work with your student. And also know I do have some paid resources that are available at acecookie-tutoring.com/shop, and those are for the ACT as well as other subjects to go along with my tutorials. And finally, just in case you're not a Facebook person, I do have an email list. So if you'd like to join that, just send an email to acecookie-tutoring@gmail.com, and we'll be sure to email you our monthly newsletter as well as our monthly specials and other goodies. Well, thanks so much, guys. We'll see you in the next video.